As we begin to look at section 8.2 here, we're going to look at exponent properties today involving quotients, whereas before we looked at just exponent properties involving products. Okay, so just like with products, there's only really two primary properties that this section is going to take a look at. The first one is if you are dividing now, right? This means division. If you're dividing two things that have the same base, then you can combine them by simply subtracting their exponents. Okay? And then the power of a quotient rule simply says, and it goes back to the idea that we can distribute an exponent to everything inside as long as you are only multiplying or dividing. If there's any adding or subtracting, you cannot distribute that exponent whatsoever. Okay, so if you're multiplying or dividing, you can distribute the exponent. If not, then you can't distribute the exponent. So, example 1 just says simplify. Okay, simplify the expression, no calculator. Now, understand something. I'm not going to expect you to simplify it down and then evaluate something if it's incredibly large. For example, what I mean by that is this. In part A here, this reduces down. This is 6 to the 12 minus 5 since we're dividing. And then we know that 12 minus 5 is 7. You're gonna leave your answer like that. Okay, I'm not gonna have you do 6 times 6 times 6 7 times. It doesn't make sense. Okay, same thing in part B. Okay, you have the same base, so you can combine them then by very simply subtracting your exponents. 7 minus 4, so it's negative 2. 7 minus 4 is to the third power. That one you could evaluate. That's pretty easy to work with. Negative 2 to the third power isn't quite as large as 6 to the 7th power, obviously. Okay, part C. Now what you'll notice is we're combining a few things. So first thing I'm going to do is I'm going to combine the things on top. Okay, I have 4 to the 2nd times 4 to the 8th. Remember from the previous video that I can combine those exponents by simply adding them together. Okay, so it's 4 to the 2 plus 8. 2 plus 8 is 10. Over 4 to the 4th, and now I can use our new property where it says if you're dividing, you can combine by subtracting exponents. So 4 to the 10 minus 4, and we all know that 4 to the 10 minus 4 is the same thing as saying 4 to the 6th. In part D, y to the 12th is the same thing as saying y to the 12th over 1, so I can multiply here. So this is going to give me y to the 12th over y to the 9th. Whoops. Okay, and now again I know I can combine the top and the bottom here. They have the same base. It's just y, and then I subtract my exponents. So y to the 12 minus 9 is really the same thing as just saying y to the third power, or y cubed is another way of saying that. Okay, example 2, part A. This is the one where we're dividing inside the parentheses here, r divided by s. So because all we're doing is dividing, I'm allowed to take my exponent to both guys inside, and so the simplified version would just be r to the 5th over s to the 5th. Okay, and there's nothing more I can do there. Part B is the same idea, right? I'm dividing inside, so I can take the 3 to both guys, so this is just 4 to the 3rd over w to the 3rd. Okay, and again, if you went ahead and did 4 to the 3rd power, 4 times 4 is 16 times 4 is 64. That'd be fine if you wrote that as 64 over w to the 3rd. We'll start doing that more and more, but right now it's just a matter of understanding the properties more than anything. Okay, it says simplify, no calculator. All right, so now that it says in these ones, we'll actually go ahead and it looks like most of our numbers are nice, so we'll go ahead and simplify as far as we can. All right, so again, there's a couple ways of doing this. What I've always done is I look at what's inside the parentheses first, right? Order of operation says do inside the parentheses first. And so what I recognize is I have a y to the 7th on top and a y to the 5th on bottom. Okay, and so by rule, I can combine those. All right, so what's left inside the parentheses? Well, the 2 is still there. It didn't go away. But now I have y to the 7 minus 5 raised to the 3rd. Okay, well, I'm going to replace that 7 minus 5. We all know what that is. Okay, we all know that 7 minus 5 is 2. And now, again, I'm multiplying inside of my parentheses, so I'm allowed to take this 3 to both things. So I have 2 to the third, and then remember when you do the power to a power, you have to multiply, so 2 times 3 is 6. And then finally 2 to the third, that's 2 times 2, which is 4, times 2, which is 8. Okay, so just do 2 times 2 times 2. So it's 8 times y to the 6 would be our simplified version here. Part B, again, first thing I would do, look inside the parentheses. The 7's not going to change. I can combine my y's here. Y to the third over y. That's y to the 3 minus 1, which is y to the second. And then the z just stays. We're not doing anything with that. Again, we're multiplying inside, so I can bring the 2 to every single guy. So I have 7 to the second, y to the 2 times 2, which is 4, and then z to the 1 times 2, which is just 2. And then the last step is we know what 7 squared is. 7 squared is 49, y to the fourth, z to the second. And that would be your final answer, simplified version. Okay. Part C, so in this one, what I would do first is, the only thing you can really do first is distribute this 3 to everything inside the parentheses. So you have 2s to the fourth over t times, now what you have is 2 to the third, t to the third over s to the third. Okay, and so now when you combine all of this, okay, you have 2 times, now this 2 to the third is really the same thing as 8, so really you have 2 times 8 on top, which is 16. And then you have s to the fourth, t to the third, over. Now, because I have s first on top and t second on top, I prefer to write my bottom so that my s's come first. So I'm going to rewrite the bottom as s to the third t, right? I've just combined these two. And so now what you recognize is I have s's, one on top, one on bottom. I have t's on top and on bottom, so I can combine them now. Okay, and so when I go ahead and simplify this all the way down, I get 16. Remember to combine, since you're dividing, you have to subtract. So it's s. On top you have 4, on bottom you have 3. So it's 4 minus 3, which is 1. Okay, so really we don't have to write it, but if you write it, it's not wrong. And then I have t. On top I have 3, on bottom I have 1. 3 minus 1 is 2. 16s t squared. All right. Part D looks a little more complicated. Guys, I probably should have mentioned this all along, but if I'm you and I'm watching this video, what I would suggest at this point is that you pause the video, try Part D on your own, and then replay the video just to kind of reaffirm that you did it correctly or to identify where you're making your mistakes. Okay, so in Part D, again, look inside your parentheses first and simplify that. 6 divided by 3 we know is 2. M to the third over m, well that's m to the 3 minus 1, which is 2. And then I have n to the second over n, well that's n to the 2 minus 1, which is just 1, so we don't have to write it. And then you still have the 3 on the outside. And now you recognize while I'm multiplying inside the parentheses, so I can take this 3 to every single term. So you have 2 to the third, m to the, remember, power to a power is 2 times 3, which is 6. And then there's a 1 there, so for n, it's 1 times 3, which is just 3. And then the very last step is recognizing that this 2 to the third really is the same thing as saying 8, m to the sixth, n to the third. And so we're just applying different properties of exponents. And then part E here, last example in the notes, is obviously a little bit more extensive, okay? Again, if you can do part E, then you're right where we want you to be, okay? Then you got this stuff down. So again, what I'm going to do is I'm going to go ahead and simplify inside parentheses first. So I'm going to leave the 4a over b squared alone for now. I'm not going to touch it. Times, now I look inside the parentheses, I know I got a 2. Okay, and now what I'm looking at is I have an a squared on top and an a on bottom, so that's a to the 2 minus 1, which is 1, b to the third, and then you have your exponent of 4 on the outside still. Again, second step, I can distribute this exponent since I'm multiplying, so I have 4a over b squared times 2 to the fourth, a to the fourth, b to the 12th, right, because 3 times 4 is 12. All over 1. And so now I take this one step further. I'm going to bring it back up top here. So now I have the 4 and the 2 on top. 4 times 2 makes 8. And then I have, let's see here, I have a and a to the fourth. But since I'm multiplying, that means add your exponents. So that's a to the fifth, and then b to the 12th on top. And then on bottom, I have just b squared times 1, which is just b squared. And so now the very last step is to recognize I have a b to the 12th on top, b squared on the bottom. I can combine those. So the 8 stays, the a to the 5th stays, and now I take b to the 12 minus 2, which is b to the 10th. And that would be my simplified expression. So you'll notice in these first two sections, all we're concerned with is becoming comfortable with properties of exponents involving products, and now properties of exponents involving quotients. Okay, so really identify, am I multiplying or am I dividing? And that determines whether I add or subtract. And then obviously a power to a power just simply means multiply. As always, any questions that come up throughout the notes, have those ready in class tomorrow, and we'll take those first thing.